Hi students, in this video we are going to discuss one question of electrostatics. It's a nice question. Now in the question it is given a point charge Q is situated at point A. A point charge Q is situated at point A which is at a distance of r which is less than capital R from the center of the sphere. And we have to find out the following things. We have to find the force acting on the charge Q. We have to find the electric field at center of sphere. We also have to find the electric field at point B. These things we have to find. Now, and it is also given sphere is having the charge Q. Sphere is having the charge Q which is distributed uniformly. Means this sphere is having the charge Q and it is given it is distributed uniformly. Now, if it is distributed uniformly in the presence of Q, it means this sphere is non-conducting in nature. Only then it is possible. Otherwise, in the presence of this charge, this cannot be uniform. Moreover, it is also given, assume that the presence of this point charge Q is not affecting the distribution of this charge. This is given because even in the non-conducting medium, due to the polarization, some redistribution of charge takes place. So they are telling neglect the polarization part, right? So the question is, we have one sphere to which non-conducting sphere to which a total charge Q is given, which is distributed uniformly. A point charge Q is placed at the center, and not at the center, at a distance of R from the center, and we have to find the force experienced by Q, electric field at center, and electric field at point B. These three things we have to find. Now, to determine the force experienced by point charge Q, this point charge is going to experience the force only due to this outside charge Q, charge on the sphere, and this charge is distributed uniformly. So electric field intensity due to uniform sphere, uniformly charged hollow sphere at any inside point is 0. So it means electric field intensity at the location of A, at A, due to the charge on the sphere is 0, and force experienced by Q is Q into electric field at this location. So it becomes Q into 0, it becomes 0. Now this is 0 because electric field here at this location due to uniformly charged hollow sphere is 0. So the force experienced by the point charge Q is 0. Now they are asking find the electric field at the center. In the system we see we have two charges. One the charge placed at A and other the charge placed at on the sphere. Electric field at center is due to the charge at Q and due to the uniformly charged sphere Q. Now, electric field intensity due to uniformly charged sphere at any inside point is 0, hollow sphere. So, electric field will be only due to this point charge. Only due to this point charge, what is the electric field? That is what we have to find. And that will be equal to K Q upon CA whole square. And the direction will be CA vector. So the electric field at center will come K 1 upon 4 pi epsilon naught Q upon CA. CA is given as R square. So CA cap. Not CA cap, it will be AC cap. Because direction will be away from the charge. AC cap. Right? Now the third part is we have to find the electric field at B due to Total electric field at B. Again, the electric field at B is due to the point charge inside the sphere plus due to the charge on the sphere. Now, due to the charge inside the sphere, point charge is K Q upon. Now, try see this vector AB. So, KQ upon AB square, and direction is AB vector. And due to the charge here, it will be radially outward from the center of the sphere, and the field will be KQ upon CB whole square and along CB cap. This will come. Now in this question, directly it is not mentioned that the conductor, the sphere is conductor or non-conductor. This we have to identify with the help of this particular statement. Right, let's take one extension of this. If this sphere is conducting in nature, let's see that also. Let us say this is center C, here a point charge Q comes, and here a charge Q is given, and this is point B. And assume this is conducting in nature. We are taking one extra question. If this is conducting in nature, if this is conducting, then because of the electrostatic induction, minus Q charge will come here, and Q plus Q will come on the outer surface. This minus Q will be non-uniform distribution, and this Q plus Q will be uniform distribution. Now they are asking, find the force experienced by Q. Force experienced by Q will be the Q multiplied by electric field at the location of A, Q. Now electric field at A is due to two charges. One is due to minus Q inner surface and due to outer surface, that is Q plus Q. This comes out to be 0 because of two reasons. Electric field due to any outside charges of conducting shell at any inside point is 0. So it is 0. Or also you can say that it is uniformly distributed charge. So due to any uniformly distributed hollow sphere, electric field is 0 at inside point. So by two reasons you can say it is 0 only. And now you have the electric field due to minus Q. Now this minus Q is non-uniform distribution, and we don't know what is the nature of this non-uniform distribution. We can't calculate this value. So it will be, we cannot determine, not possible to find. Within JEE advanced syllabus scope, right? Now the second thing they said, find out the electric field at center. Now electric field at center will be due to plus Q, due to minus Q, and due to capital Q plus Q. This is 0. This we can find. It will be KQ upon AC whole square into AC cap. But this factor, again, we don't know how the charge minus Q is distributed on the inner surface of the conductor. So this we cannot find. So it means we cannot find the electric field at point C also. Now the next part is we have to find the electric field at B. If we have to find the electric field at B, now we know any conducting shell divides the entire space in two parts. So here, this inner region and this outer region. Electric field at this point due to this and this charge, minus Q and plus Q, which are inside, is 0. At point B, electric field is only due to the charge capital Q plus small q on the outer surface. So electric field at point B is only due to q plus q, because due to plus q, small q, and due to minus q, it will be 0. And why it is 0? From the properties of behavior of conductors in the electrostatics. Now, when you have to find this particular thing, it will come out to be k q plus q upon cb square. We have outside point, uniform distributed charge sphere can be considered as the charge is located at center. So cb, this distance, cb whole square, and direction will be cb cap. This will come, right? In next video, we'll discuss some more questions. That's all for now.